Showing you how to do the exercises that go along with the video lesson, Solving Basic Equations, Part 1. Are you ready? Let's get started. Our first problem is solve for x. X plus 6 equals 18. So to solve for x, we need to get x all by itself on one side of the equal sign. But right now, 6 is being added to it. So to undo addition, we need to use subtraction. So we'll subtract 6 from both sides. And doing the subtraction to both sides will keep our equation in balance. So on this side, we have x plus 6 minus 6, and the plus 6 and the minus 6 cancel out, leaving just x. We have x equals, and on this side, we have 18 minus 6, which is 12. So x equals 12. For problem 2, we have 5 plus x equals 19. And so we need to get x all by itself. Right now, it's being added to 5. Last time a number was being added to x, this time x is being added to a number, but because of the commutative property, that's the exact same thing. This is exactly as if we had x plus 5. So we can use minus 5 to get rid of that 5, and we do that to both sides. So on this side, the positive 5 and the minus 5 cancel out, leaving just x. And on this side, we have 19 minus 5, which is 14. So x equals 14. For problem 3, we have 30 equals x plus 22. So we need to get x all by itself. So we need to subtract this 22. And we need to do that to both sides. So on this side, we have 30 minus 22, which is 8. And on this side, the plus 22 and the minus 22 cancel out, leaving just x. So we have 8 equals x. And so x is all by itself on one side of the equal sign. But for it to read better, it's better to have x on the left side of the equal sign like this. So x equals 8. For problem 4, we have 24 equals 13 plus x. So to get x all by itself, we need to get rid of the 13 here. The x is being added to the 13, and because of the commutative property, it's the same as the 13 being added to the x. So we subtract 13 from both sides. And on this side, we have 24 minus 13, which is 11. And on this side, the positive 13 and the minus 13 cancel out, leaving x. We have 11 equals x, and we'll rewrite that as x equals 11. For problem 5, we have x minus 7 equals 3. This time a number is being subtracted from x, and to undo subtraction, we use addition. So we'll do plus 7 on both sides, and on this side, the minus 7 and the plus 7 cancel out, leaving x. On this side, we have 3 plus 7, which is 10. So x equals 10. For problem 6, we have 40 equals x minus 15. So to get x all by itself, we need to get rid of that minus 15, and we undo subtraction with addition. So we add 15, and we do that to both sides. On the first side, we have 40 plus 15 equals 55. And on this side, the minus 15 and the plus 15 cancel out, leaving just x. And so we have 55 equals x, or x equals 55. For problem 7, we have x minus 14 equals 5. So to get rid of that minus 14, we need to add 14 to both sides. So we have x minus 14 plus 14, and the minus 14 and plus 14 cancel out, leaving just x. And on this side, we have 5 plus 14, which is 19. So x equals 19. For problem 8, we have 14 minus x equals 5. Now this time, x is being subtracted from a number, and since subtraction does not have the commutative property, 14 minus x is not the same as x minus 14. So what we'll do is we'll add x to undo the minus x, and we'll add x to both sides. So we have 14 minus x plus x, and the minus x and plus x cancel out, leaving 14. And then we have 5 plus x, and we just keep that written as 5 plus x. So this didn't completely solve the problem, but with just one more step, we'll be there because this is a version of the problem that we know how to solve. Because addition does have the commutative property, we can just subtract 5 from both sides. And on this side, we have 14 minus 5, which is 9. And on this side, positive 5 and the minus 5 cancel out, leaving x. So we have 9 equals x, or x equals 9. And we mentioned in the video that this was a slightly easier way because you don't have to deal with negative numbers as much. So I'm going to show you where if you are comfortable with negative numbers, you might actually prefer this way. So I'll rewrite the whole problem. We have 14 minus x equals 5. And so we'll go ahead and get rid of this 14. And even though subtraction doesn't have the commutative property, it's a positive 14. So we can subtract 14 from both sides. And on this side, positive 14 and the minus 14 cancel out, leaving negative x. And on this side, we have 5 minus 14, which is negative 9. We're trying to solve for x, and we know what negative x is, but we want to solve for positive x. So when you have a negative number, if you want to flip it to a positive number, you just multiply it by negative 1. So we'll multiply both sides by negative 1. I'll put parentheses around it so it's clear that it's a separate group from this x here. And then multiplication is implied, so we know that we multiply that. Put negative 1 here, we're going to multiply that by it. So negative 1 times negative x is x, and then negative 9 times negative 1 is 9. So we get the same answer both ways. We have x equals 9, x equals 9. So if you're comfortable with negative numbers, this method might be easier for you. Both methods require 2 steps, but whichever is easier for you is fine. You get the same answer either way. For problem 9, we have 64 minus x equals 17. So in this case, I'm just going to show you the way we did it in the video. And we're going to add x to both sides. On this side, the minus x and the positive x cancel out, leaving 64. And we have 17 plus x. All right, so now we need to get rid of this 17. So we subtract 17. We do that to both sides. And on this side, we have 64 minus 17, which is 47. And on this side, the positive 17 and the minus 17 cancel out, leaving just x. So we have 47 equals x, or x equals 47. For problem 10, we have 10 minus x equals 12. So we'll add x to both sides. On this side, the minus x and the plus x cancel out, leaving just 10. On this side, we have 12 plus x. So we need to get rid of this 12. So we'll subtract 12 from both sides. On this side, we have 10 minus 12, which is negative 2. And on this side, the positive 12 and the minus 12 cancel out, leaving just x. So we have negative 2 equals x, or x equals negative 2.